Hello GATE aspirants, welcome to part 7 of GATE Electromagnetic Theory series. Question number 2. Which of the following magnetic vector potentials give rise to uniform magnetic field B naught K cap? So here we have to calculate del cross of K A for each case. So this will be equal to, first option we will check, dou by dou x, dou by dou y and dou by dou z. This will be 0, 0 and B naught z. So this will be equal to, since this will be dou by dou y of z, so this will be 0 only. For the second case, del cross of A is equal to I, y, z, and here we have minus of B naught x. Here we have terms dou by dou y, dou by dou y and dou by dou z. And next we have here, this is z cap, so this will be 0 here, minus of B naught into x, and this will be 0. So this will again be, this will be 0, 0, and last term will be z cap, dou by dou x of this, so this will be minus of B naught into z cap. So here this is also wrong. Now for C, del cross of A, this will be equal to I cap, y cap, z cap, dou by dou x, dou by dou y, dou by dou z. This is I cap. For I cap we have B naught by 2 into minus of y, and this will be B naught by 2 x and 0. This will be equal to z cap. This will be B naught by 2 minus of this, so plus B naught by 2 into z cap, so that is B naught z cap. So option C is correct. And for option D, you can see this is both, this will be plus plus, so here we will have minus sign, and that will give us 0. So for the last one it will be 0. So option C is correct. Next question. The magnitude of the magnetic dipole moment associated with a square shaped loop carrying a steady current I is M. If this loop is changed to a circular shape with the same current I passing through it, the magnetic dipole moment becomes Pm by pi, where the value of P is. Now magnetic moment is current into area. So initially it is square shaped loop. So let its side be A. So this will be I into A square. For the second case, same current is there. So I into area of that circular loop, it will be pi r square. But that is the same loop. So length will be same. So perimeter will be same. So 4a perimeter of square loop will be equal to circumference of circular path. So from here we can see r is equal to 4a by 2 pi, or this will be equal to 2a by pi. So let us substitute here. So I into pi, and r is 2a by pi square. So that is 4a square upon pi square. So this will be equal to I into 4a square upon pi. But I into a square is m, so this will be 4 into m by pi, and this is equal to pm by pi. So by comparison, p is equal to 4. So here answer is 4, and answer in the answer case 4 to 4. Next question. In a Young's double slit experiment using light, the apparatus has 2 slits of unequal widths. When only one slit is open, the maximum observed intensity on the screen is 4 I naught. So here I1 is given, that is 4 I naught. When only slit 2 is open, the maximum observed intensity is I naught. So I2 is equal to I naught. When both the slits are open, an interference pattern appears on the screen. The ratio of the intensity of the principal maximum to that of the nearest minimum is. So here we have to find I max upon I min. So this will be equal to under root I1 plus under root I2 upon under root I1 minus under root I2 whole square. So this will be root of 4 I naught plus root of I naught upon root of 4 I naught minus root of I naught, the whole square. So root of I naught it will cancel throughout. Root of 4 is 2 plus 1 upon 2 minus 1 square. So 2 plus 1 is 3 square, that is 9, and 2 minus 1 is 1 square, that is 1. So answer is 9. So here answer is 9 and the answer in the answer key is 9 to 9. Next question. An infinite conducting slab kept in a horizontal plane carries a uniform charge density sigma. So we have a conducting slab like this which is carrying charge density sigma. Another infinite slab of thickness T made of linear dielectric material of dielectric constant K. So here we have another material whose dielectric constant is K and whose thickness is T is kept above the conducting slab. The bound charge density on the upper surface of dielectric slab is. Now bound charge density is equal to, for that we have to calculate P first. So bound charge density is equal to P bar and its direction, perpendicular direction, so that will be Z cap. So if we consider this vertical direction as Z, then this will be Z cap dot. So this we have to calculate. So this is the bound charge density and this P is equal to, P can be written as, this will be epsilon naught into chi E into E bar, where this is susceptibility, which can be written as K minus 1. So epsilon naught into K minus 1 into E bar. So for this we first have to calculate E bar. Now this is the conducting plate and we know electric field due to conducting plate, this will be equal to sigma by epsilon into, and this will be in the direction of Z cap. So epsilon can be written as K into epsilon naught to sigma upon K by epsilon naught into Z cap. This is electric field. Now polarization P is equal to epsilon naught into, we have K minus 1 into E bar. But E bar is this, so sigma upon K epsilon naught Z cap. So this will be sigma into K minus 1 upon K Z cap. So this will be P bar. And P bar dot Z cap, this will be equal to sigma into K minus 1 upon K. So here option D is correct. Next question. The electric field component of a plane electromagnetic wave traveling in vacuum is given by this expression. The Poynting vector for the wave is. Now Poynting vector S bar is equal to 1 by mu naught into, we have E bar cross V bar in free space or in vacuum. So this will be equal to V bar, it can be written as E naught by C. So we can write here V bar is equal to E naught by C. So this will be E naught. If we calculate magnitude, then we know B naught is equal to E naught by C. So I am using that here. So this will be E naught square upon mu naught by C. So that will be E naught B naught, and also we have here cos function. So this will be cos square of kz minus omega t, because that phase will be same for E and B, and we have to find its direction. Now this wave E bar is in I cap direction and K is in Z direction, and E bar cross B bar, it should be in direction of K bar. So that means B has to be Z cap. So that will be E bar is equal to I cap cross Z cap. So this will be in direction K cap. Now we know C square is equal to 1 upon mu naught epsilon naught. So from here we can see 1 upon mu naught by C is equal to epsilon naught into C. So this we will use here. So this will be epsilon naught C into cos square kz minus omega t into, we have E naught square as well, K cap. So here option D is correct. And the way we have calculated this is B naught is equal to E naught by C, and same phase will be there. So that means cos of kz minus omega t, and its direction will be Z cap. And E bar here is E naught into cos of kz minus omega t I cap. So use these values here. You will get this. Option D is correct here. Next question. The xy plane is the boundary between the free space and a magnetic material with relative permeability mu r. So it will be in xy plane. So let us consider this is xy plane. The magnetic field in the free space is Bx I cap plus Bz k cap. The magnetic field in the magnetic material is. So here also we will use boundary conditions. Now magnetic field perpendicular component is or normal component is continuous. So B1 perpendicular will be equal to B2 perpendicular, and it is in xy plane. So the k component will be same. So this will be equal to Bz k cap. So that is perpendicular component. And in parallel component we have H1 parallel, and since there are no free charges here or free currents here, so free current density here, so this will be H2 parallel. So this will also be same. So we can write here B1 parallel upon mu naught because it is free space, and this will be B2 parallel upon mu, but mu can be written as mu naught into mu r. So from here B1 parallel or B2 parallel is equal to mu r into B1 parallel. This will cancel out. But B1 parallel is Bx I cap, so this will be mu r into Bx into I cap. So finally B2 bar is equal to mu r Bx into I cap plus Bz k cap. So here option D is correct. So these were all the questions from GATE 2016 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.